This is half past paper week 22 for foundation. So calculator paper again this week. This is all the even numbers. We did the odd numbers of this paper last week. So even numbers this week. And these are all of the topics that we're going to be covering on today's paper. 41 marks in total. It was 39 last week, making 80 in total for the past paper. Okay, question number 2. Change 3 metres into centimetres. So 1 metre is 100 centimetres. So if you're going from metres to centimetres, you would be timesing by 100, and from centimetres to metres, you'd be dividing by 100. So we're going metres to centimetres, we're going to multiply by 100, so that is 300 centimetres. For question number 4, simplify m, add m, add m, add m, and that is 4m. Remember, if you're doing m times m times m times m, then that is m to the power of 4. So people always confuse those, so just have that in mind. If you're timesing, that's going to increase the power. If you're adding, you're just collecting them up and saying, I've got 4 of them. Simplify 12p divided by 4, and that is going to be 3 lots of p. If you've got 12 lots of p, dividing it by 4, it's going to be 3 lots of p. Question number 6. Here's a list of whole numbers from 21 to 30. From the list, write down a square number. So your square numbers are the answer you get when you times a number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. These, 1, 4, 9, 16, 25, 36, they are all square numbers. So from this list, the only square number is 25. Seems appropriate to put it in a square, but there we go. 25 is your square number there. From the list, write down a multiple of 8. Multiples of 8 are numbers in the 8 times table. So 8, 16, 24, 32, 40, and so on. So from that list, I'm going to write down 24. There we go. Question number 8. 5 students throw a dice. They each throw the dice the same number of times. The diagram gives information about the number of times the dice lands on each number. Work out how many times each student throws the dice. So we know that the number 1 was thrown 6 times between the students. The number 2 was thrown 4 times. The number 3 was thrown 5 times. The number 4 was thrown 8 times. The number 5 was thrown 7 times. And the number 6 was thrown 5 times. If we add all of those together, 6 add 4, add 5 add 8, add 7, add 5, that's 10, that's 15, and that's another 10. So that's going to be 15, 25, 35 times. So in total, the dice was rolled 35 times. And so we then just need to divide that between the number of students, and we're told in the question that there were 5 students. So 35 dice rolls divided between the 5 students means they rolled it 7 times each. So 7 is our answer for that one. Okay, question number 10. Write 17 as a fraction of 30. Not a trick question. It is asking you to write 17 out of 30. Question number 12, and this is testing our ability to use a calculator. Now, if you do not have a Casio scientific calculator, I would really recommend getting one for your GCSE exams. It's just going to help you out massively. In particular, I'm looking for buttons that have a square root symbol on them, and I'm looking for the button that has the fraction symbol like this on them. Now, in this case, because the square root goes all the way around the fraction, I want to press the square root button first and then press the fraction button. If you pressed it the other way, so if you press the fraction button first and then the square root, you'd end up with just the square root on the top of the fraction, and we don't want that in this question. So press your square root first, then press the fraction button, and then you're just typing 13.82 at the top, and then you're going down, use that down arrow on your calculator to get the denominator, so 13.82 divided by 4.06 on the denominator, and that is 1.844977205. All the figures on your calculator display. Now, if you didn't have a Casio scientific calculator, you could just do 13.82 divided by 4.06, and then whatever your answer is, press the square root button, and that would get you your answer, the same answer as well. Okay, part B, give your answer to 2 decimal places. This is your first decimal place, the first number after the decimal point. This is your second. We check the next number, and because it's a 4, it rounds down. 5 and above, you round up. 4 and below, we round down. So that's just going to be 1.84 to 2 decimal places. Question number 14. Nazima uses this graph to find out how much money she is paid for the number of hours she has worked. How much money is Nazima paid for each hour that she works? So here we go. Here we can just see that after 1 hour, if we read up, hit the graph and we go across, it looks like 16 or 15, but let's be sure, okay? So I don't think that's massively accurate. Well, yeah, I guess it is in the middle, isn't it? There we go, we'll say 15. But if we weren't sure, what we can always do is see from here that after 2 hours, it is 30. So that makes me happier that every hour is £15. 1 hour is 15, 2 hours is 30. Graphs are always a little bit easier to read. The higher up you go, you're less error. So there we go. How much money she paid for each hour she works? Well, every hour she gets another £15. So that is £15 per hour. Last week, Nazima worked for 36 hours. How much money was she paid? Well, we know that she's going to get £15 for every hour that she works. So we just need to do 36 times by 15. And we do, of course, have our calculator for this. So 36 times 15 is 540. If you didn't have your calculator, my favourite method for this would be to do the lattice method. 36 times 15. Split every box diagonally and make it a little bit longer somewhere to put your answer. 6 times 1 is 6, 6 times 5 is 30, 3 times 1 is 3, and 3 times 5 is 15. And then you just add down each diagonal section. So we've got 0 there. 6 add 5 add 3 is 14, so 4, carry the 1 into the next section, and 0 add 3 add 1 is 5. So there we go, you also get an answer of 540. Question number 16. The pie chart gives information about the colour of each car in a car park. There are 135 black cars in the car park. So this section is 135 cars. It's 90 degrees. We can see that because we've got that right angle there. Work out the number of white cars in the car park. Okay, so there's a couple of different ways that we could do this, but the first thing I want to do is say 135 cars equals 90 degrees. What we want to get is 80 degrees because 80 degrees is the number of white cars. So what would be helpful here? If I want to get to 80 degrees, I could do with finding out how many cars 10 degrees is worth. There's lots of different ways you could do this, okay? You could find out how many degrees one car is, but I think it's easier here to just say, right, 10 degrees is worth, I'm going to divide that by 9. So if I divide 135 by 9, I get 15 cars. So I know now that every 10 degrees is worth 15 cars. And so if I want to go to 80, I could just take that off, or I could times by 8. And so 15 times 8 is 120 cars. Or you can do 135 take away 15, because 90 take away 10 is 80. So there we go. It is 120 cars is your answer for that one. There are 50 grey cars in the car park. A car in the car park is picked at random. Find the probability that this car is grey. Well, what we need now is to know how many cars there are altogether. Now we can see that a quarter, 90 degrees, is worth 135 cars. So if this much of my pie chart is 135, then to find out how many cars there are in the car park altogether, I just need to multiply that by 4. So I'm going to do 135 multiplied by 4. 135 times 4 in my calculator is 540 cars altogether. That's the total. So the probability of picking a grey car is 50 out of 540. You don't need to simplify the fraction. For probability, we're always okay to leave it as it is. If you did simplify it, that's absolutely fine. That would be okay as well. And I can just do that in my calculator by typing 50 over 540. And that simplifies it as far as it can go, is 5 over 54. So they were just both in the 10 times table. There wasn't anything more you could have done there to simplify it. Either of those answers, though, would get you both marks. Okay, question number 18. The incomplete table gives some information about the lengths of the planks of wood in Ben's workshop. We've got a missing value there. The total length of these planks is 92 metres. Work out the number of planks of length 2 metre in Ben's workshop. Okay, so we know that there are 5 planks that are each 3 metres long. And so altogether we can multiply to find out how long those planks of wood would be altogether. 3 times 5 is 15 metres. So that's 15 metres altogether coming from those 5 planks of wood that are each 3 metres long. And I'm just going to carry on multiplying the ones that I can. So if I've got 8 planks of wood that are all 2.5 metres long, in total I can do 8 times 2.5, which tells me that they are 20 metres long altogether. If I've got 14 planks of wood that are all 1.5, I'm going to do 14 times 1.5, which is going to be 21 metres altogether. And again, I've got 10 planks of wood, all 1 metre long, and we know that that's going to make 10 metres. Now this needs to add up to 92. They've told me in the question that the total length of all of the planks of wood is 92, and we've got a missing value here. So let's add up what we know so far. From the 15, the 20, the 21 and the 10, I'm just going to use my calculator. 15, add 20, add 21, add 10 is 66 metres. So what's missing? If these 4 values make 66 metres, I'm going to do 92, take away 66, and that is 26 metres. Now we now know that this value here must be 26 metres. But remember that each of the planks of wood are 2 metres long. So how would it add up to 26? We need to know what number here would multiply with 2 to give 26, and that would be 13. 26 divided by 2 is 13. 2 times 13 would give me 26. So there are 13 planks of wood that are 2 metres long in Ben's workshop. Okay, question number 20. Simplify c to the power of 5 divided by c squared. When we divide, we take away the powers. I'm doing c times c times c times c times c for c to the power of 5, and I'm dividing it by c times c. So that's going to cancel out, and that would be the same as c cubed. When we divide, we take away the powers. A power of a power, like we're doing here, we times the powers together. I'm doing d to the power of 4 times d to the power of 4 times d to the power of 4, because I'm cubing it. I'm multiplying it by itself and then by itself again. D to the power of 4 times d to the power of 4 times d to the power of 4. And when we times, we add those powers. So that is d to the power of 12. But a power of a power, there was a shortcut there. You can just times those numbers together. 4 times 3 is 12. So there we go. Question number 22. Find the highest common factor of 60 and 84. So the highest common factor is the biggest number that fits into both of those numbers as a factor. There is a method, and we're going to do the prime factorisation of both of those numbers. So we're going to start with 60 at the top here, and we're going to split that up into 2 numbers that multiply together to make 60. Now these can be any numbers you like. When you get to a prime number, you're going to circle it, and then if it's not a prime number, you're going to carry on. So your prime numbers, remember, are 2, 3, 5, 7, 11, 13, 17, 19, and so on. They're numbers that are only in the 1 times table and their own times table. So 60, I'm going to split that up to be 6 times 10. Why not? Now, neither of those are prime, so I'm going to carry on with both. 6 is 2 times 3, and they're both prime. And 10 is 2 times 5, and they're both prime. There we go. So 60 is 2 times 2 times 3 times 5. With 84, let's make that 42 times 2. 2 is prime. 21 times 2. And then 21 is 3 times 7. So 84 is 2 times 2 times 3 times 7. We're then going to do a Venn diagram for both of those numbers. This circles for 60, this circles for 84, and in the middle I can put a 2, because they both have a 2. I can put another 2, because they both have another 2, and they both have a 3. So 2, 2 and 3 can go in the middle. I've got a 5 left over out here for 60, and I've got a 7 left over out here for 84. The highest common factor is the part that fits into both. So we want to multiply all of these numbers together in the middle. 2 times 2 times 3, and that is 12. So 12 is the biggest number that is a factor of 60 and 84. Now you might think, well, that's a lot of work for doing that, but that method will always work no matter how big the numbers are, so it's a really good method to know. Okay, for part B, find the lowest common multiple, and we can do this in the exact same way. You can just list 24, then 48, then 72, and so on. And because you've got a calculator, you might find that an easier way to do, and you can just keep going. 96, add another 24 is 120, and then if you go 40, 80, 120, the lowest common multiple is going to be 120. It's the first number in both their times tables. However, let's see how we can use that method at the top again. So 24 is 8 times 3, which is 2 times 4, which is 2 times 2. So 24 is 2 times 2 times 2 times 3. And then let's just do the same with 40. 40 is 8 times 5, 2 times 4, and 2 times 2. So then if I have my Venn diagram, this circle's for 24, this circle's for 40, and in the middle we can put 2 and 2 and 2 because they all have those 2's. 24 has 3 left over and 40 has 5 left over. So your highest common factor is 8. You would then times that by any numbers left on the outside, so by 3 and by 5, and that is 120. So we get the same answer either way, but it's good to have a method just in case you want it. That is the method seen above. All the numbers in the middle times together, that's the highest common factor. Multiply that by any numbers left on the outside, and that is your lowest common multiple. Or you can just list both numbers, but people tend to go wrong, like be 1 out or 10 out when they do that. So just be really careful if you are going to list the numbers that way. Okay, question number 4. Complete the table of values for y equals x squared minus 2x add 2. Now you do have a calculator for this paper, so you can just type this in your calculator. I'm going to do it both ways. You can use the table of values function in your calculator, which I've done videos on separately, or you can just use the bracket method. Now, I really like the bracket method. I think it's quite simple, quite straightforward. So in my calculator, I'm going to type this, but every time there is an x, I'm just going to put brackets. So in my calculator, I'm typing bracket, bracket squared minus 2, bracket, bracket, add 2. And then all I'm going to do is use the left-hand arrow of my calculator. So you've got that top button like that. I'm going to just use this left-hand arrow to go back and put whatever x value I want in the brackets. So bracket, bracket squared, minus 2, bracket, bracket, add 2. And then back in those brackets, I'm going to start by putting minus 1 in both of those brackets. Now, if you put minus 1 in both the brackets and you hit equals, it tells you that that is 5. Now, the beauty of this method is now all you need to do is use that left-hand arrow and go back to both of those brackets and just change it to 1 instead of minus 1, because that's the next number that we need to work out. And when we do that, I get 1 as my answer. Now we're just going to go back to both of those brackets and change it to be a 2. And that gives me an answer of 2. And then again, I'm going to go back to both those brackets and change both of the inputs, both of the x's, to be 4. And that gives me an answer of 10. I'm happy with that, okay? So all I was doing there, let's just show you with the 4, is putting the 4 where the x is here and where the x is here. So to get y, you need to do 4 squared minus 2 lots of 4, add 2. And by putting it in brackets, you make sure that any negatives are squared correctly. So 4 squared is 16, take away 8, add 2, and that is indeed 10. So that's how we got that answer there. You're just using this as your rule. And now we've got to draw it. So each of these is a coordinate that we're going to plot on the graph. So minus 2, 10 would be here, minus 1, 5 is going to be here, 0, 2, 1, 1, 2, 2, 3, 5, and 4, 10. And now you're going to join that up with a nice smooth curve going through all of the points and making sure that it's not pointy at any at the bottom there. It should be a nice smooth curve. So touching that, oh yeah, I'm going to redo that like this. And coming back up like that. There we go. And that is a quadratic graph. And we've had to draw it between minus 2 and 4. So there we go. It then says use your graph to find estimates of the solutions to the equation x squared minus 2x add 2 equals 4. Now this is what we've just drawn on the graph. X squared minus 2x add 2 is what we've just drawn. And they would like to know, when does it equal 4? Now to find out when it equals 4, I'm going to draw a line going across at y equals 4. When does y equal 4? When does the graph equal 4? And there's two places. Here is one place it equals 4, and here is another place it equals 4. So for that, I'm looking at those values there, and I'm going to say that that is minus 0.75, and let's go with with 2.75 as well. So minus 0.75, or, and you can say and if you want, 2.75. Let's go with that. You might have said 2.7, 2.8, or anywhere in between, or minus 0.7, minus 0.8, or anywhere in between. That's absolutely fine. Okay, question number 6. ABC is a right-angled triangle, and this is immediately giving me SOHCAHTOA vibes. It's a right-angled triangle. We've got an angle involved, and we're finding out a missing side here. So we want BC, which is this one over here. First thing we're going to do for SOHCAHTOA, SOH, and TOA, is to label our sides. So always, wherever the right angle is, here, you're going to go over, and that is your hypotenuse. You're then going to stand in the other interesting angle. Over from that is your opposite, and next to that angle, that's the adjacent. So those are your three sides. Now we need to determine what is involved. So the opposite is the thing we're trying to work out. That is definitely involved, or we want that involved in our formula triangle. The adjacent, we know, is 12, so that's quite helpful information. With the hypotenuse, I don't know how long it is, and I don't want to know how long it is. It's not the thing we're trying to work out, so therefore that's not going to be helpful in my formula triangle. That leaves me with A and O. So hopefully it makes sense if I say we're going to use TOA here. So in TOA, cover up the thing you want to know, which is the opposite, the O, and do the sum that's left behind. Now remember, SO, the S stands for sine of the angle, so sine 56. If I was using CA, it would be cos 56, but we're using TOA, so that T is tan 56. So T times A is tan 56. Don't forget to shut the angle after the shut the bracket after the angle, times by the adjacent A, which is 12. Typing that in my calculator, tan 56, shut that bracket, multiplied by 12 is 17.79073, and they want that to one decimal place, so I'm going to put 17.8 as my answer. Then we have PQR is a right angled triangle. Work out the size of the angle marked X. Give your answer correct to one decimal place. Again, this is SOHCAHTOA, but this time we're finding an angle. This is your hypotenuse, this is your opposite, and this is your adjacent. Now the opposite, I don't know how long it is, and I don't want to know how long it is. A and H are going to be involved here, so this is going to be CA. Now with your CA triangle, with all of the triangles, this bottom left-hand letter is your angle. So here, because I want the angle, if I cover this up, I know that cos of X is the adjacent over the hypotenuse. And because we want that angle, I need to undo that cos. So we're going to say cos to the minus 1 of 15 over 18. The A, the adjacent, is on the top. The H, the hypotenuse, is on the bottom. So to get that cos to the minus 1, you're going to press shift and then cos in your calculator. I like to use the fraction button as well, 15 over 18, but you can put 15 divided by 18, that's all fine. And that gives you 33.5573 to one decimal place, 33.6 degrees. And last but not least, question number 28. In a sale, the normal price of a boat is reduced by 15%. The sale price of the boat is $272,000. Now that means that someone has already taken 15% off. If you start with 100% and someone has already taken 15% off, what you're left with is 85%. So the first mark here is going to come from 272,000 equals 85%. So you're recognising that actually 15% has already been taken off to give that value. Now I think the best value to get here would be 5%, but you can do it however you like. You might want to divide by 85 to get 1%, that would be absolutely fine. I'm going to go for 5% just because I think it's a little, no, do you know what, I'm not, I'm going to go for 1%, why not? So 1% I would find not by dividing by 100, but by dividing by 85, because I'm only starting with 85%. So dividing both sides by 85, I'm going to get 272,000 divided by 85, which tells me that 1% is 3,200. If you then want to know what 100% was, the original, the normal price of the boat, I'm just going to times that by 100. So times by 100 is 320,000. That would be your answer there for 2 marks. Okay, fabulous. That was all 41 marks of that paper. Hopefully you found that helpful. Let me know in the comments if you've got any questions at all, you want me to go over anything again, and I will see you guys next week for week 23.